So we are going to start our session. Am I audible?
Yes, ma'am, you're audible.
Okay. Or we can wait for 2 minutes, then we can start. Maybe
Okay.
3 people will join. So let's start the session. This is week 2 problem solving session, Microelectronics device to circuit. I'm Arpita Biswas, the PhD scholar from IIT Jodhpur in electrical engineering department. I'm pursuing PhD. So this is more details about me, that I did my BTech from Macau and I did my MTech from IIT Jabalpur in Microelectronics, and this is the time schedule of this class every Tuesday 7 to 9 p.m. So in this session we are going to discuss some question, some MCQ question and some numericals. So let's start the session. So this is the first question. So I think all of you will be able to answer this question. So this is the first question, that the statement is so you have to find this statement is true or false. So the first statement is the main function of a BJT is acts as an amplifier and also it acts as a switch. So what is the right answer, and please explain it, why? If it is true, then why, and if it is false, then what is the reason behind it?
BJT can be used both as amplifier as well as a switch. For a switch, when we are operating the BJT cutoff mode, we put your off switch, and in a saturation mode, put the on switch. And when the BJT is acting in active region of operation, it can act as an amplifier.
Okay, good. Sutharsan, what is the right answer? Sutharsan, Ramesh. Please unmute yourself. In which condition BJT acts as a switch? In which condition BJT acts as a switch? Or in which mode?
Switch in cutoff and saturation.
And in saturation mode, can you explain what about the bias voltage?
Saturation, that is on switch and cutoff become switch.
Base emitter junction is in which bias?
When base emitter junction is biased in saturation.
रिकॉर्ड हो
base
रहा
emitter
है
and
ऐसा इसका
base conductor region of forward bias and saturation region, and both the junctions are reverse bias in collector.
okay. And in which mode BJT acts as an amplifier?
In active mode and reverse active mode.
Tarun, what is the right answer? Okay. Tarun, what is the right answer? Tarun, please unmute yourself. Okay, so we are moving towards the next question. So the next question is you have to find this statement is true or false. So the collector current is the collector current is the number of holes and the number of electrons. So actually this question is the collector current is depends on the majority and minority carrier on both. So is this statement is true or false? If yes, if it is true, then please explain.
Ma'am, the statement is true because IC is equals to alpha IE plus IC P naught, where IC P naught is the minority current and the maximum current will count as the majority. As the carrier that is generated from the emitter terminal is the majority of the collector current. But few part of the IC P naught is also there, which is a minority.
Okay. Tarun, please unmute yourself. Okay, so we are moving towards the next question. So question number 3 is
Ma'am,
which
is
of,
my answer correct? Because
yes, it is depends on both the majority and minority carrier. So this statement is true. So this is the question number 3. Which of the following is the formula for
muted.
you are not. I'm not audible. Hello.
Now you're audible.
Okay. Okay. So this is the question number 3. Which of the following? Hello.
Yes, and the last one was true.
Yes, the last one is true. Which of the following is the formula for current gain of the common emitter based amplifier? So first option is the change in collector current and by change in the base current, and the second option is the change in the collector current by change in the emitter current, and the third option is the change in the base current by divided by the change in the emitter current, and the fourth option is all of the above. So please take your time and then try to get the answer.
Option A will be the right answer. For common emitter amplification, it is IC by IB.
Okay. And for the other students, only one student, two, Tarun and Shaurav. And what is the condition of the previous class? Yesterday you also have joined, na?
Yes, and yesterday there was almost 14 students plus 14 students.
Previous class, 3 students. It's difficult. Okay, we'll continue our session. But Tarun, at least unmute yourself and try to give the answer, no? Hello? Tarun? Because for only one student in the class, it is very difficult. I think we'll go to the next question. Yes, there's the collector current ICY, common emitter based. So here ICY IV. So the right answer is the change in the collector current and change in the base current. So the next question is a device that amplifies a weak signal to a stronger signal is called. First option is the amplifier, the second option is the rectifier, the third option is the transmitter, and the fourth option is the all of the above. And this is a very basic question, I think. You can give the answer.
Then option A will be the right one.
Can you little bit explain about amplifier, what you understand about this and what happened?
Amplifier is basically a device that actually amplifies or increases the amplitude of the signal. So it makes us it strengthen a signal. So that's why it is called an amplifier. Where in a BJT the common emitter configuration is mostly preferred configuration as it is having the highest high gain. So amplification is very high in case of the common emitter. So amplifier is basically a device that can amplify or strengthen a signal from weak signal to strong signal. So it is an amplifier.
And what do you understand by small signal amplification?
Small signal amplification means basically in high frequency model that takes place where we amplify our small signal. In small signal model, weak signals means basically the signal that is a weak in amplitude. So that is a weak signal. So that can be amplified and the amplitude is strengthened so that it can be used for better communication purposes.
Tarun, you can unmute yourself. There is only 2 students, so you can unmute yourself and you can give the answer. So what is the right answer, Tarun?
The right answer is option A.
Okay. And can you explain about amplification or amplifiers?
Amplifier is an electronic device that increase the strength of the weak signal.
Okay.
The
Okay.
expected amplitude is frequencies.
Okay. So next we are moving towards the question number 5. So question number 5 is, which of the following is the formula for voltage gain of the common emitter based amplifier? So first option is the current gain into the output collector resistance divided by input base resistance, and the second option is the current gain into output emitter resistance divided by input base resistance, and the third option is the voltage gain multiply with the output collector resistance divided by input base resistance, and the fourth option is the both A and B. So what is the right answer? You can take your time, then try to give the answer. Which of the following is the formula for voltage gain of common emitter based amplifier? Current gain into output collector resistance by input base resistance. Second option is the current gain into output emitter resistance by input base resistance. Third option is the voltage gain, output collector resistor divided by input base resistance. So the right answer is the first option. Current gain, which is beta for common emitter based amplifier. Current gain beta into output collected resistance by input resistance. Okay, so the first option is the right answer. So next we are moving towards the question number 6, that what is a transconductance amplifier? Have you heard this word, the transconductance? What is the meaning of it, or what we understand from it? Hello, am I audible? Hello?
Yes, ma'am, you're audible.
So have you heard about this word transconductance?
Yes, ma'am. Transconductance is basically it is created by GM. The formula of GM is reverse of del IB by del VB.
Tarun, have you heard about this transconductance? We know the amplifier means it is amplifying some signal. So if you know about what is transconductance, what is changing, and because in everywhere where we are read about this amplifier, we know that we are giving some input signal, and then it's amplifying its amplitude, or the power. If we are want the amplification of any case, then it is the amplitude is amplifies. Okay, so it means some input we are giving in small input we are giving, and it is we are getting the large something. So what is the transconductance, and what is input here, and what is the change of it means something is changing in the output now.
Ma'am, it's actually the input is a voltage and in the output we get a current.
Yes. So so from the transconductance amplifier, what we understand from it? You take your time. Try. At least try.
Ma'am, it is basically a device that generates a output as a current with the help of the difference of the input voltage.
So the transconductance GM is del ID by del VGS. It means the output current is changing with respect to the input voltage. So small amount of
voltage,
yes. So small amount of voltage we are changing, and there is a large change in the current, output current.
Output current.
Okay, so this is called the transconductance amplifier. Tarun, are you getting the point?
Yes, ma'am.
Now can you explain what is transconductance, and what do you understand from this transconductance amplifier?
And basically, transconductor amplifier is measure the input signal with respect to the output signal current.
No, actually this is del ID by del VGS. It means change in output voltage. Change in output current with respect to the change in input voltage. VGS it means the base to emitter side. But GS actually this is with respect to the MOSFET VGS.
VB, del VB.
Yes, del VB. Okay, so the change in output current with respect to change in input voltage.
Del IC by del VB.
Yes. Samuel, please unmute yourself. Samuel. Okay. So we are moving towards
Yes,
the next.
madam. Yes, madam.
What do you understand? Yes. Actually, I want all of you participate in this session. Not only you just muted and I'm just giving the explanation. At least you people try. Then if you are not able to give the answer, then I will lastly explain. Okay. So this will be more interactive session. Okay. So what do you understand from the transconductance?
The change in the voltage source in the input and result in the output current.
So how we
Del I by del EV.
okay, so del IC by so transconductance is symbol is GM, so GM equal to del IC by del VGS. It's mean change in input.
Output current the input resistance.
Yes,
Input voltage.
Okay, good.
Thanks.
So next we are moving towards the question number 7. So at which frequency common emitter based BJT amplifier voltage drop happen? High frequency, low frequency, mid frequency, or both A and B? Have you heard about this BJT amplifier where the voltage drop happen? Okay, Samuel and Tarun. Actually, I'm not getting that you are not liking this type of MCQ question, or you are interested only the numericals. So I can change my way of teaching. So is this okay? There's some MCQ, some theoretical concept we can clear here, and
Yes.
also some numerical question we can discuss here.
Both are equally important. Because
Yes.
Without this concept, the numericals cannot be evaluated.
Yes. So actually, I'm taking some MCQ, so you can clear your theoretical portion, and as well as we can we can discuss some numerical question here.
Yes, ma'am. You continue with this one.
Okay. So if you are facing something that it is not okay, I have to change something, so I can change it. If you are interested only in numericals, then I can put some numerical question here, and I can only solve this, and because I only have to take one and a half to 2 hour, so I can cover it anyway, whatever you people want. But first, before going to the numerical question, I think little bit MCQ of this theory portion is okay. That's why I'm discussing. Actually, this question is very little bit easy. But when you are going to solve some numericals, I think little bit theoretical you have to clear. It's a theoretical concept. That's why just I'm checking your theoretical concept, and then we can go for the numerical question. Otherwise, I can also take 10 or 12 question and I can solve here. And if you want some that I will teach some theoretical as Sari is teaching. So like that way we can also continue. That first we can discussion. If you have any topic that I want to discuss, then you can say next day I will come and I will discuss this topic, and then we can go for the session. And you can also. Yes, actually the theoretical portion is the sir already taught, and also it is shared. But if you are facing to understand some topic also,
Possible in the next week, in the next session of Tuesday, that is in 15, if you can discuss a part of the second order effects of BJT, that will be helpful.
okay, actually, okay, you can also directly mail me. So it will be little bit easy to remember these things. Okay.
Okay.
So this is my mail ID is given or not, I don't know. I'm sharing it in the chat box. because in theoretical portion also, if you are facing some issue, then you can tell me that I have to learn this. So in the next session, at first we discuss about this topic, then we go for some MCQ theoretical question, and after that we can solve the some numerical question. Okay, so I posted my mail ID, so you can share the topic which you want that I have to discuss. Sagar, what is the right answer? Samuel? Actually, in my session, I am expecting that all of you will participate.
Midterm.
Tarun, what is the right answer?
I'm option D.
Okay, option D. Okay, so the right answer is the both, high and low. Okay. So next we are moving towards little bit numerical question. So can you solve this? For a transistor, beta is 45 and the voltage drop across 1 kilo ohm which is connected in the collector circuit is 1 volt, and find the base current for the common emitter connection. So please try to solve the question. So here beta is given. We know that beta is IC by IB, and the voltage drop across RC, that's when the resistance is 1 volt, and the resistance value RC is 1 kilo ohm. So find out the base current for common emitter connection. So IB we have to find here. Beta is given, so if you can find out the IC, then it is a little bit easy to find out the IB. And I want the answer from all of you and with the explanation how we solve it.
Ma'am, the VGC value is given.
VCC, I think you have to find it just no, VCC it is not given. You have to find out the at first the VCC, and then
And the VB value is 0.7 VB.
yes, the VB is 0.7. VCC and VBB is not given. Only given is the resistance value and the voltage drop across it. So when the voltage is given with respect to any resistance, so here we can find out the current passing through it. So from there, this is the hint. So from there you have to find out the current. Somewhere you can unmute. Sorry, you can mute yourself, and when you are going to give the answer, this time you can unmute.
Ma'am, IC is coming at 1 milliampere.
Okay.
IC 1 milliampere is coming.
Okay. And then
So IB will be equals to by beta.
And what is the value?
So it will be 1 by 45. Microampere.
Yes. Tarun, what is the right answer and how to solve this question?
Here the voltage drop across the collector resistance is given. So that means we know that the VC's value is 1 volt. The collector voltage drop across the collector segment is 1 volt, is VC is 1 volt, and the RC value is 1 kilo. From there we can find the IC, that is by RC. So that will come as 1 milliampere, and I can find the value of IB equals to that IC by IB equals to beta, IB equals to IC by beta. So 1 by 45, that will come as 22.22 microampere.
Yes. Okay. Tarun, IC is 1 milliamps. Okay. IC is 1 milliamps. Then what is the value of IB?
Ma'am, 0.022 milliampere.
Okay. So have you understand this circuit? How you have calculated this IC? Because only here that voltage drop is given. So we have to just divided this voltage by this RC value. So we can get the IC. Okay. And from there here the beta is given, that is the 45. So the beta is IC by IB. Directly just put the value and you can get the answer. Samuel, please unmute yourself. So,
just not practicing much problems at this time. Next time only.
have you understand?
Problems not practicing much, no.
Sorry, I'm not getting you. Have you understand this circuit? How to solve the problem?
Circuit is not able to display on my laptop.
Circuit. You are not able to see the circuit.
Madam?
Are you facing any issue?
Yeah, I'm not able to see circuit in my laptop. Yeah, just sometimes it's doing somebody circuit around 50. Earlier I logged in mobile for those days. Now in laptop, the problem not able to see.
So in mobile also you can see, na?
Then I will see the
Or I can share, or you can see this. Actually, I have already uploaded the PPT, so you can see from there also. Na, question number 8. Okay, I'm sharing the link. From there you can. I'm sharing the PPT in the chat box. Okay, I'm sharing the link. You can find from there. Just a minute. I'm sharing my Google Drive link because I want all of you, whoever is present in our in my session, all of you at least try. I'm not expecting that all the answer you will give, but at least try. If you are not able, then I will explain it. Just wait for 1-2 minutes. I'm going to share the PPT.
Arpita?
I have shared my Google Drive link. Can you share see from here? Question number 8, week 2. Now can you see the slide or this circuit? And please try to solve how to solve. And if you are not able to do, then I will explain. Samuel, can you access the Google Drive this week 2 session? PPT of this week 2 session? We have to complete lots of questions. So please little bit hurry. Hello?
I logged in mobile, madam.
So now can you see the slide? Or you can directly access the slide now. I have shared in the chat box.
Yes, madam.
So question number 8, can you see the circuit?
Yeah, I'll open it.
Week 2, question number 8.
In mobile, yeah, I opened in my mobile, madam.
So now you can see the circuit.
Okay.
Can you see the circuit? Hello?
Yes, madam.
So please try to solve the question. So here what is given? The beta value, which is the current gain, is given, which is 45, and the voltage drop across the one. Here you can see the RC, which is the resistance, is given in the collector side, and the value of the RC is 1 kilo ohm. So beta is given, the RC value is given, and the voltage drop across this RC is given, which is 1 volt. So you have to find out the base current. So how we will find out the base current? Because here beta is given, and we know that the beta is IC by IB. So here you have to find the value of IB. So before, hello?
Yes.
Yes, so
Yes, madam.
how you will find out? Is the question is clear? Beta is given, the resistance is given in the collector side, and the voltage drop across this resistance is given. And we know the beta is IC by IB, and the IB value is we have to find out the IB. So at first we have to calculate the value of collector current, so IC. So how we will find out the IC value?
I see. BCC by RC, madam.
Yes. Actually VCC is not given, only that is given the voltage drop across the RC. Okay. So if the voltage drop across any resistance is given, so in that time the current passing through that resistance you can find out, na? Voltage by normal equation, the voltage by resistance you have to give, and you can find out the current, and that current is the collector current.
1 volt by 1 kilo ohm is IC.
Okay, so the IC value is 1 milliampere. So then you have to
1
find out the IB and the beta value is given. Then find out the IB.
Okay.
Beta equal to IC by IB. So you find out the IC value.
IB is required, madam.
So IB you have to find out.
Okay.
If the voltage drop is given across any resistance, then you have to find out the current through passing through it is the simple equation that V by R. Okay, so you are getting the current which is the value of IC, and then beta is given the current gain which is IC by IB. So here IC by IB equal to 45. Then IC is given. You have to normally just find out the IB value.
Okay, madam. Okay, I found that.
So
Okay.
you understand?
Okay, okay. 45. Okay. IB is equal to beta into beta into 1 milliamps.
See, just a minute.
45. 45 into 1 milliamps. 45 milliamps.
How it will 45 milliamps?
No, madam. One minute.
Just a minute. Just a minute. I'm sharing again.
Not.
Just a minute. I'm showing. Now you can see my slide. Just a minute. I'll show.
Okay. Yes, madam. Question.
So what you have to do? At first you have to find out the current passing through this. Okay. So IC equal to simply 1 voltage by 1 kilo ohm. So what is the value of it? 1 milli. Okay, this is clear. And then we have to find out the base current. Here beta is given.
1 by 45, madam. 1 milliamp plus 45.
Yes. So beta equal to
1 milliamp plus 40.
IC by IB. So this is 45. Then what is the value of IB?
0.022 amp milliamp. 0.022 milliamps, madam.
Yes.
So 22 microamps.
Okay. Good.
22 microamps.
So we are moving toward the next question. Question number 9. So the next question is: a transistor is connected in a common emitter configuration in which collector supply is 8 volt and the voltage drop across the resistance RC connected in the collector circuit is 0.5 volt. The value of a RC is 800 ohm. If alpha is 0.96, then determine the collector emitter voltage and the base current. So take your time and then try to solve.
Ma'am, the base current is 26 microampere.
Yes, that is 26 microamperes.
And ma'am, the value of DCE, that is the collector to emitter voltage, is 0.5 volts.
VCE is 0.5. No, VC is not 0.5. The voltage drop across the resistance is 0.5.
Okay, got it.
So you have to see first what is given here, what is the name. So the voltage drop across the resistance is given and then VCC is given. So we have to find out the VCE. So here from this loop, just take this loop. So from this loop you will got the first answer, okay? And when you got the first answer, VCE value, then you just have to find out the IP. Yes.
Ma'am, 7.37.
No, VC is not 7.37. How you calculate? Can you please little bit explain? Just take the loop now, the
I
VCC.
have taken the loop analysis, so which can be we can consider the minus VCC, minus VCC minus of ICRC plus.
Just a minute. Just a minute. When you are taking minus VCC, when it is going to, let's see the sign. Here it is minus, this is plus. And it's the resistance. If you are taking this side, this current is from this type. It means this side is positive and this side is negative. Okay.
Yes.
And now calculate.
Then it will be minus VCC plus 0.5 divided by 800. Then
Why? Just a minute. You are only calculating the voltage, okay? And now you divided by this 800. The simple logic is there. This is very much easy question. Only the voltage is given. So just to,
7.5.
yes, the right answer is 7.5. How it is? The first loop, if we are taking that this minus to, if we are going from minus to plus, then it is positive. Okay, I'm just taking this.
Sorry, I consider the voltage.
Okay, then 8, then plus to minus, minus 0.5. Okay, go,
Then plus
then if it is,
minus VC.
yes, plus, and this is minus, so plus, we are going to minus to plus, we are taking, just you can assume anything, like if you are going to plus to negative, then you can, if you are considering it, then opposite will be opposite sign. Okay, minus to plus, you are taking the positive, so plus to minus, it is minus, then plus to minus, it will minus VCE equal to 0. So what is the value of VC?
7.5, madam.
Yes, the value of VC is 7.5. Then you calculate the IB value. How you calculate? And this question is little bit similar to the previous question.
Now, if we get the VC voltage 7.5, then we can divide that voltage by 800, so we can be getting the value of IC.
Then
And if we get the value of IC, then we can get the value of emitter current by, as we are having the alpha. So emitter current will be IC by alpha, and if we get the emitter current, so IB will be emitter current minus collector current.
okay. So from here we can calculate the beta value. Okay. At first,
Beta also we can value, yes, so beta
you
alpha
can
by 1
just
minus alpha.
go for the easiest process, na? Here alpha is given, you can directly go for the beta, you can find out the beta, then from the beta you can directly get the IB value. Samuel and almost student.
The beta value is 24.
Okay, beta value is 24. Tarun, how to calculate this? Have you understand this? How to calculate this BCE? Samuel, have you understand this and how to calculate the? Okay. Find out. Tarun,
23, madam. Beta.
no, beta value is 24.
23, I got it. Okay.
How you calculate? Beta is alpha by 1 minus alpha. So alpha value is 0.96. Then 0.96 by 1 minus 0.96. So recheck the calculation. So what is the value?
0.96 by 0.04.
Saurabh, what is the value of beta?
24.
Yes. Please Samuel recheck the calculation. Directly you can calculate, no?
Okay, 24, correct, madam.
Okay.
Calculation, so beta we got.
Okay. So as we have done in the earlier question, so here you can find out the IC value. If any voltage drop across any resistance is given, so you can find out the current passing through this resistance. So the current passing through this resistance is also equal to the IC, na? So from the 0.625 milliampere. So how Samuel, how you calculate this IC value?
Collector current have to find, no, collector current 0.5 by
0.5 by?
0.8 kilo.
Okay.
0.5 by 0.8 kilo.
So you calculate at first. You have calculate.
Yeah.
So you have to find out the IC value.
And 625 milliamps. And 625 milliamps. I see.
Yes, and then you also have calculated the beta, because we have to find out the IB. So beta equal to alpha by 1 minus alpha.
IC by beta.
So here just directly put the value 0.96 by 1 minus 0.96. So beta equal to 24. This is the current gain. So IC by IB equal to
26 microamps.
24. Just put the value of IC and you can get IB equal to
26 microamps.
26 microamps. Tarun, have you understand how we calculate this? How to calculate the collector emitter voltage and the base current?
Yes, ma'am.
Okay. So we are moving toward the next question. Or if anyone having any issue to understand this, so we can wait for it, and you are solving the question. So in that time we can wait for you. Okay, but at least try. So this is the next question, question number 10. So determine the VCB in the transistor circuit shown in the figure 10, and the transistor of silicon and has beta value is 150. So beta value is given, you have to find out the VCB. So this is the collector side, emitter, this is the base. So which voltage is VCB? That portion. Okay, this is VCB. So you have to find out the VCB, and beta is given. Beta is 150. It's when IC by IB value is given.
When the base current is 0.43 milliampere,
Question number 10. Yes, the base current is 0.43 milliampere.
and then the collector current will be 64.5 milliampere.
64.5 milliampere.
Then the collector to base voltage is minus 1.45.
Collector to base. It's when VCB value is minus something.
Yes, minus.
No. Try it. You can take your time. And other student also, Samuel and Tarun, please try.
Harmless, madam. Just first question of the calculation.
Okay, take your time. Yeah, sure.
Then the collector to emitter voltage, that is VCE, is coming as 3.55 volts.
Okay. Right.
Then so if the emitter is grounded, then the VCE will be so if it is solved, then the collector voltage value will be 3.55 volts.
Okay. What is the value of VCB?
So VC means only the collector voltage is 3.55 volts. That's the is value. And if I can find the value of VT, that is base voltage, then I can find the value of VCB, that is VC minus VB. So base voltage times VT. So base voltage is 5 volt. I can find the VCB.
Actually, you are taking. You just have to take that VCE equal to VCB and VB. This is a simple equation. Okay.
Sorry ma'am, can you please state once?
VCE. Here VCE is equal to VCB and plus VB. Just you
Oh,
have
yes,
to
yes, that-
apply this equation. And we know that for the common emitter, VBE value is
From 2.85 VB the answer.
yes, the right answer is 2.85 voltage. And for the other student also, please try to solve, and then I will explain here how to. Tarun and Samuel, at least try. Take some time and then at least you think how to solve. Here only thing is given is the VCC is given, RC value is given, RB value is given, also the input voltage, the VBB is given, and we have to find out the VCB. And here I have written one equation that VCE equal to VCB plus VBE. So the collector to emitter, as it is a common emitter connection, so VCE, the collector to emitter voltage, is equal to the voltage across this VCB plus the VBE, and we know that the value of VBE is for the common emitter is 0.7. So here we can easily find out the VCB if you know the value of VCE. So at first we have to find out the VCE, this voltage. This voltage you have to find out. So this is the loop, you have to take it first. First from here you can find out the theta. First you can take this loop, okay, and second okay, the loop, and here you can find out the IB. First calculate the IB value, Samuel and Tarun.
Yeah, I will do them. IB is equal to VBB by 10K.
VBB
By 10K.
and also some
So 5 by
voltage
10K.
here, no? Here is a
5 by
VBE.
10K.
How
So
find?
0.2 milliamps.
No. This is not the right way to solve this. Just see the equation. Here nothing is given. It means this is the emitter, no? So this is the base to emitter junction is there. So here VBE also present. Okay, it is not written, but here it is also present, and the value of VB in common emitter is 0.7 volt is here. So then try to solve.
Loop again. VBB minus IB
VBB minus
IB RB minus
yes.
VBB is equal to 0.
So IB into 10k ohm minus 0.7 equal to 0. Then you have to find out the IB. Tarun,
VBB minus.
are you getting my point? First you have to find out the IB value, because only beta is given. So if beta is given, it means IC by IB value is given. So if you can find out the IB value, then from the beta value you can easily calculate the IC value, and if you are getting the IC value, then from there, from this second loop, this is the second loop, okay, this is the second loop, so from there, this is the second loop and this is the first loop. You can calculate the VCE value, and if you are getting the VCE, then you can easily find out the VCB, as VBE is 0.7. Calculate and tell me what is the value of IB.
43 microamps, madam.
Yes, 430 microamps, I think. Just calculate.
43
No?
microamps. Then
Just see the first equation. Someone just see the first equation. 5 minus IB,
I see how to find IC, no, madam.
10K minus 0.7, okay, equal to 0. Just calculate in the right way.
I see how to find it.
So IB equal to 0.43 milliamps. Is this someone?
45.15 milliamps. I see.
IC value?
45.15 milliamps. I see.
IC value is 64.5 milliamps. IB value is matching with your answer, 0.43 milliamps. 5 minus 0.7, 4.3. Then it will be this side, 4.3 by 10 kilo ohm.
Okay, madam, that is okay. I see, I am telling.
Okay.
I see.
Then what is the value of IC? Like here
IC,
beta is given. Okay. So IC you have to find out. Here you can read it.
45.15 milliamps.
IC equal to just
45.15 milliamps.
150 into 0.43.
0.43 milliamps.
Just multiply this 150 into 0.4 3 milliamps or 430 micro.
64.5 milliamps.
Then what is the value of this?
64.5.
Yes, 64.5 milliamps. Okay. Then find out. Then taking this loop. You know now you know the IC value.
Yes, yes.
Now tell me
VC how to find it.
VCE. What is the value of VCE?
VC is equal to 10 minus ICR.
Just you have to take this second loop. Okay.
Yes.
So 10 minus
3.55 minutes.
minus
3.55 volts.
yes 3.55 volts. Then what is the value of
BCB.
BCB? Tarun, are you getting the answer, or you are facing some difficulties to solve this question? Do you understand this now up to this? Tarun? Hello? Tarun, please unmute yourself. If you are facing any issue, then please tell me. VCC minus IC RC. IC value is already 10 minus 64.5.
Madam, VCB is equal to 2.85 volts, madam.
Yes, 2.85 is the right answer.
Okay, thank you.
So here you can find out receiver. BCB. So, solve the next question. For the circuit shown in the figure, draw the DC load line. So, at least try how to find the DC load line.
Ma'am, can I say?
Yes.
Ma'am, for the common nature consideration, if you plot the output characteristics graph, that is the IC versus DC, where the input is the base current is the input, so we can get the load line as 12.5 volt in the exactly DC value, and IC value we are got as 5 milliamps.
Okay. And how you calculate it? Only from the
And the equation is that is the equation we are getting is VCC minus ICRC minus VC equal to 0. So keeping the VC equal to 0, we can find the value of IC equals to VCC by RC. So VCC value is given as 12.5 volt and the RC is 2.5 kilo ohm. So the IC will be coming as 12.5 by 2.5, that is 5 milliampere IC value.
someone.
And
Okay, you're right. Your answer is right. Someone, have you understand it? How to calculate the DC load point? Someone?
I'm thinking, madam, still.
Okay.
Load line I can draw, but now this according to these parameters, I'm thinking.
Okay.
VCC is required, IC is required, VC is required for
Okay.
load line.
Okay. You do. Calculate. Tarun, have you understand? What is DC load line and how to calculate it and this circuit? Just take the simple equation from this loop, because here no signal is given. So what is here? So this is it. So you have to find this point, okay, and this point. This means the where is the IC value is 0. From this equation, now this is the equation number 1. So here just you have to put when IC value is 0, then what is the value of VCE? And first calculate this, and then you have to calculate when VCE in that point. What is the value of VCE? 0. Then what is the value of IC? This you have to find out. Okay? So tell me, what is the value? This is the load line. Tarun? Now you can tell me now what is the value of this DC load line? What is the value of VCE and this IC? When the IC value is 0, then you have to find out the VCE. Then this is the value of this point. And then when the VCE value is 0, then you have to find out the IC. And from this equation, all the things is
IC is 0, which is equal to VC. VC is equal to VCC.
So what is the value of VCC? It is already given here, 12.5.
12.5 volts.
And what is the voltage of IC?
0.
No. When VCE, here you have the IC is 0, you have to find out the VC. The VC value is given the 12.5. And when next coming to the second, this is the first now, and then next coming to the second point, when VCE is 0, then we have to find out the IC. Same equation, you have to put the VCE value 0 and find out the IC. And what is the value of
by
IC?
RC. By RC. IC equal to VCC by RC.
And what is the value?
12.5 by VCC by RC. 12.5 by 2.5. Five milliamps, madam.
Yes, 5 milliamps. So it is the answer here. 12.5 comma 5 milliamps. Tarun, have you understand? Please unmute yourself so you can go for the next question. Okay. So please try to solve this. Determine whether or not the transistor in figure is in the saturation mode or not. Assume the VNE equal to 0.2 voltage. So you have to. Here you have to just find out this circuit is in saturation mode or not, and the D voltage is given. Now
The
tell me.
voltage is given at 0.2, that means it is a germanium, because VV is 0.2 means the device is germanium. So by calculate I'm getting it is the device is the transistor in saturation region of operation, because a transistor to be in saturation mode of operation, the VB, the base emitter should be Then the value of IB is coming as 0.28 milliampere.
Question number 12. The IB value is 0.23 milliamps, I think.
Madam, here VB for germanium 0.1, madam. 0.2.
Here knee
Knee is
voltage.
VB, madam.
Okay, knee voltage is given 0.2, and all the things are given. You have to just find out that the circuit is in saturation mode or not. The transistor is in saturation mode. Tell me how you decide that it is in saturation mode or not. At first you have to find out the IB, okay, the base current, and then you have to find out the collector current, and then you have to see that much IB is here or not. So we can say that the transistor is in saturation mode. At first you have to find out the transistor current, the collector current is in saturation mode. When it is saturation mode? From this loop, no? At first you have to find out the IC saturation. Okay, find out, and then you have to find out the IB value, and also the beta is given. You have to find out the IB value, the beta value, and then you have to again find out from this IB what is the value of IC. Okay, and then you have to recheck that much IB value is here, so it can reach up to this IC saturation current. So if it is equal to or greater than this IC saturation current, then you can say that this transistor is in saturation mode.
But the IC sat is 10 milliampere.
No, little bit less than 10 milliamp.
IB is 0.8 milliamps, madam. 0.8 milliamps.
How you calculate it? You have to take the circuit, the loop. So tell me what is the equation?
280 microamps.
VCC. Then minus I saturation into RC minus for the saturation mode, this is called knee, na? I think VCE will be the knee voltage, V knee. Okay, so V knee equal to 0. So from here you have to find out the IC saturation value. So when the transistor is in saturation, then you have to assume that the transistor is in saturation. Then you have to calculate from, yes. So what is the value of this? So this will be the 9.8. Somewhere you have to calculate it how this 9.8 milliampere is coming.
And the IB value is 0.19.
And the IB value is you can directly take the VBE value is 0.7. Here just yes, you can take directly the value of VB is 7. Here is the VB, no?
0.23 milliampere.
VB is
IB is
just a
0.23
minute.
milliampere.
Just Samuel, have you got the answer? This IC value is 9.8 milliamps. Have you calculated?
Not did, madam.
Oh, okay.
I have to substitute this. IC sat is
Just
9.8. We got one.
yes. Just put this 10 voltage minus IC saturation.
This equals VCC minus IC sat RC minus VC. This is
Yes. Equal to 0. Okay. From this first loop, from this loop, we are getting this 10 minus 1 kilo ohm into IC saturation minus the knee voltage, which is 0.2. And from there we can calculate that IC saturation is 9.8 milliampere. So are you getting?
VC is 0.2, madam.
The knee voltage is point C. from this side.
VC
Just
VC is point. It is germanium, madam. 0.1, no, madam. VC.
no, not take the germanium. Here already given in the question that Vni is 0.2. Then why you are taking this 0.1?
VC.
Just take 10 minus I saturation into 1 kilo ohm. 1 kilo ohm. Sorry, this is minus. Minus 0.2 equal to 0. Here you can see now Vni is given. So here you have to, this is 1 kilo ohm and this is I saturation.
Madam, VC is the voltage at which the
Just this collector to emitter. Okay, so
input voltage.
VCE.
Madam, VC is the input voltage, no, madam.
No, here Vni is not the input. Just see. Here Vni voltage is not the input voltage. VCE value when IC is saturation, that time the voltage is 0.2. Now prove.
Okay.
Now you are getting. So from here when you calculate now, so you will get yes I saturation equal to
9.8 by
yes
1 kilo ohm.
9.8
milliamps.
milliamps.
9.8 milliamps.
Yes.
Okay, thank you.
Okay. Then you got, and then what you have to find out the IB value.
IB 280 microamps, madam.
Now IB is 0.23 milliampere.
Yes, 0.23. And how you have to calculate? Just take the
VBB minus VBE by 10
this
kilo
loop.
ohm.
Yes, just took this loop. VBB minus IBRB minus 0.7. Samuel, please calculate the value of IB.
0.23.
Yes. So now what we have to find out?
0.23 milliamps.
So this is the saturation current, okay? And this is the bit IB, base current. So from there, and also the beta is given. Calculate.
So IC is 11.5 milliampere.
Yes. So then calculate IC value. Yes, the IB value is, sorry, the IC value is 11.5 milliamps. Samuel, please calculate this. How to calculate the IC from IB?
If we get the IC value, then can we determine the value of DC, and it is coming as minus 1.5 volt DC collected to emitter voltage.
Actually, there is no need to find out anything else. You can see that the saturation current is the IC saturation current is 9.8 milliamps. Okay, and from the beta IB value, you have find out the 0.23 milliamps. So when from the beta, you are finding the value of IC, and IC value is 11.5.
Yes, ma'am.
11.5 milliamps, which is greater than this saturation current. See, I saturation means IC saturation, na? So IC saturation value is 9.8, and from the beta, which can able to generate the collector current, which is 11.5, which is greater than this IC saturation. So in this case, can we tell that this circuit is in saturation mode, because this input current can able to get the higher or equal amount of this IC saturation current. So it can reach up to this saturation level. So we can tell that this circuit is in the saturation, or the transistor is in saturation. Have you
Ma'am,
got
can
my
you
point?
repeat once more?
Okay, first we have here we have find out that I saturation when the transistor is in saturation. So we are getting some IC saturation current. Now what we have done here, we have find out the input current. So the input current IB we have find out, and then we have find out what is given here, the beta value. So from the beta value again we are calculating the IC value, and then we are comparing that. If we are taking the input current that amount, this 0.2, so we are able to reach that current when the transistor is in saturation, then the 9.8 milliamps. And when we are and this in this circuit we can find out that then IB is 0.2, so it can reach the IC value is more than the saturation, so it is in saturation mode. So if it is less than the 9.8, then it is not in the saturation mode, it is some active or some cutoff mode. No, if the BV value is 0.7, then it can be obviously in active mode, but it is not in saturation mode. For the saturation mode, when the current is stable, you can see that. Okay, so if it is the more than the saturation voltage or equal to the saturation, then we can see that yes, that much input current we have, so we can able to reach that stage. Okay, so this circuit is in saturation. At first in the saturation mode the current we have calculated, and then we have find out the input current, and from the input current we are again calculating the output current. Output current is means the collector current, and then we see that here we can see that the IC current is greater than the IC saturation. So we can obviously say that this circuit is in saturation. Samuel, do you have any doubt?
Yes, madam.
Or is it okay?
Yeah. Okay.
Have you find out the value of IC?
I have found number 0.23 milliamps.
See, beta value is 0.23, then IB value is 0.23, then beta value is 50. Then from the beta is IC by IE, IC by IB. Okay, then you have to find out the IC value when the beta value is 0.23. Okay, and from there you can see the IC value. Just put here.
Okay.
IB equal to 50. Then you have to find out the, here we know that IC by
IC by IB.
IB. By 50. So you know the IB value. Just multiply with the IB value with this 50. You can get the value of IC. This is 11.5 milliamps. So up to this, do you have any doubts? Or I can explain again. Samuel?
Clear then.
Samuel?
Yes, madam.
Do you have any doubt that this circuit is in saturation? Why it is in saturation?
I have found up to IB value and IC sat, madam. After that, what to find?
No,
Not
see.
follow.
Okay. Let's see. At first, what we have calculated, the IC current when the circuit is saturation. Okay. Then we have find out the IC sat. It means the IC current when the circuit is in saturation, then the current value is 9.8. Then what we have done? We have calculated the input current, which is 0.23, and now we have calculated the IC current from this IB and the beta value, and we have find out that the IC current is 11.5. Now you can see that the IC saturation current and the IC only the IC current, where we are calculating this IC current from the input base current. So which value is okay? So then IC current value is greater than this IC saturation current. So if it is equal, yes. So in that condition we can say that this circuit is in saturation mode. Okay, why? So we have that much amount of input current, so it is able to produce this IC current which is greater than this IC saturation current. Okay, that's why
11.5 milliamp.
what is 7?
11.5 milliamp.
Yes, 11.5 milliamps, and this value is greater than this IC saturation value.
Yes, sir.
So in that case, we can tell that we have that much input base current that is able to produce this IC saturation current, which is greater than this IC saturation, or if it is also equal to the IC saturation, in that case we can tell that this circuit is in saturation mode. Up to this, do you have any doubt?
Okay, madam. Fast. Calculated.
Yes.
IC greater than IC sat.
Yes, or equal to IC sat. In that case, we can tell that this circuit is in saturation mode. Okay.
Okay.
So we have that much input current. So it can able to get that much output current. Okay. So this circuit or transistor is in saturation mode. So now we are going to solve some MCQ question. So little bit easy. So what is the right answer? Which of the following source is applied as an input to BJT amplifier? AC, DC, or all of the above?
So option A.
AC.
AC.
Yes.
AC.
Yes, the right answer is option A. And next question, it is also very easy. I think in the last class also we have discussed this question. Which of the following is the value of base emitter voltage for common emitter BJT amplifier? 0.7, 0.5, 0.1 and 0.2. Samuel, what is the right answer? It's when we are asking about
0.7. 0.7,
yes,
madam.
0.7. Oh, good. So this is the question number 15. What is the value of output of an common emitter based BJT amplifier? 0, 1, inverted or infinite?
1. Option B. 1.
Can you little bit explain?
Ma'am, the value of output. No, sorry.
Inverted, madam.
It is inverted. Samuel, can you explain?
Inverted, madam.
Can you explain what is the meaning of inverted and what you are getting in output?
Inverted means as we are getting a negative gain,
Yes,
so that is 180
yes.
degree phase shift.
Yes.
180 degree phase shift, so inverting out.
Yes.
Correct, madam.
Yes.
In CA amplifier, there is a 180 degrees phase shift. The gain will be with negative sign. The negative sign indicates inverted signal.
Okay. Good. So next we are moving to the question number 16 for BJT to AC and as an amplifier, which operating region is preferred? Substation, saturation, cutoff or linear? For amplifier, which region we have used?
Active
Linear.
Linear will be the right answer.
Yes,
Linear.
Why linear? If you are taking in the saturation or cutoff, what will happen?
Q point. In linear Q point.
Yes. Because this you can see that type of. Okay. So this
VTC voltage
yes.
transfer.
So if this linear actually this I think this okay, this is linear region. So here is the Q point. So if we are taking in saturation, this is saturation, then what happens? The output will 0 or 1. And if we are operating the cutoff mode, the output will 0. And if we are operating in, then the output will on. Okay.
Saturation on, madam.
Okay.
Saturation on.
Yes. So when we are okay. So when we are operating in digital mode, we need 1 or 0. So then in that situation, we can use this saturation or the cutoff mode. But in this linear region, we have used as an amplifier. So small change in input can we can find that the larger change in output. Okay. So this is the linear region. So next question, operating point shift can occur in an amplifier due to which of the following? Input frequency variation, noise at the input, parasitic, capacitance or power supply fluctuation. Parasitics means the internal capacitor. I think you already know about the parasitic capacitor, the internal capacitors.
I think option B will be the right answer. My noise at the input. So the few point shift.
Samuel, what is the right answer?
1 minute, madam.
Operating point or Q point is shift can occur in an amplifier due to which of the following?
Noise, madam.
No. This is the internal capacitors or the parasitic capacitors.
Parasitic capacitance, madam.
Yes.
Parasitic.
Yes. So next question is gain of the BJT amplifier is dash close to 1, 0, 1 or infinite.
1. Unity gain.
But ideally it is not, I think, 1. It is nearly equal to 1. Okay. So all right option is close to 1. Samuel?
Madam, voltage fall over, madam, 1, close to 1.
Yes, close. A common emitter based BJT amplifier acts as a dash type of amplifier. Current, voltage, load or all of the above.
All of the above.
Samuel, what is the right answer? Common emitter based.
Voltage amplifier.
Yes. The right answer is the voltage. Next, which configuration of the BJT is used for the impedance matching?
CC, madam.
CC, common collector.
Yes. Common collector. Then question number 21. Common base configuration in a BJT has dash input resistance and dash output resistance. First option is the low and low. Second option is the low and very high. Third option is the high and high. And the fourth option is the none of the above.
Then option D, low and very high.
Yes, the right option is the option D. Samuel?
Low and very high.
Very high. Then the question number 22. The inverse mode model of BJT is valid for only in active mode, only in active and saturation mode, only in active cutoff mode, and option D is in active saturation and cutoff mode for all three.
D, madam. D.
All
D.
the mode.
Yes. Option
D.
The question number 23. The cascade amplifier is a multi-stage configuration of CC, CB, CE, CB or CB, CC or common emitter, common collector.
Option D, C, CP. Common
Yes.
emitter, common base.
Yes, the right option is common emitter and common base.
Hello, it should be I think cascade amplifier, right?
Sorry, I'm not getting
Is it
it.
written as cascade?
Yes, cascade or cascade, okay.
So is it cascade or cascade amplifier?
This is actually
I
written
think it
as
should be
the
cascade, right?
okay. This is cascade or cascade. You can take anything, okay. Then what is the right answer?
No, actually cascaded and cascade both are different kind of amplifiers.
This is the cascade type of amplifier.
Cascade means we can cascade it to different types of amplifier. But cascade has a separate type of amplifier, no? Like cascade with common emitter and common base.
Okay, actually I will recheck it, okay. And Shora, do you have any idea about it? The cascade or cascade?
I think if the answer is common emitter followed by a common base, then the amplifier will be cascade amplifier. Cascade like for cascading different types of amplifier in a cascaded manner. That could be anything like common collector and common base. That is also cascaded pattern. But I think it should be cascade.
Okay, I will recheck it.
Madam, cascade means any two amplifiers or more than two can be connected.
Coupled
One after
amplifier. RC coupled amplifier.
Okay. And cascode or what is the difference between the cascade or cascode? Sure.
Ma'am, cascode actually the special type of connection where you dedicatedly cascading common emitter followed by common base. And cascade like for any like whatever RC couple that is cascade or common emitter followed by a common emitter. That could be cascaded form. If I want to multiply higher gain, in that case we are getting the cascaded form of the amplification.
So next question.
Ma'am, option A will be the right answer. 56 microampere.
Can you please explain how you can calculate it?
IC sat I have to determine because IC sat will be equal to VCC minus VCE sat by RC. So VCC is 3 volt minus VCE sat is 0.2 by RC is 1 kilo ohm. So 3 minus 0.2 divided by 1 kilo ohm. So I am getting the value as 2.8 milliampere. IC sat is 2.8 milliampere.
Okay.
And then IP minimum will be IC sat by beta, so 2.8 milliampere divided by 50. So the value will come as 56 microampere or 0.056 milliampere.
Okay. Samal, have you calculated this?
Not yet, madam. I am just thinking.
Suraj? Sorry, Suraj. What is the right answer?
Actually, I have not any like pen paper. I have not taken.
I don't think that much equation you have to solve. Just you have to find out the value of IB.
Yeah, I see the approach is someone is told that is correct. And I see if I have to find the IC and IB that should be a IC by beta.
Okay, and how you will find out the IC value?
Yeah, as it is in saturation, so VP drop always 6.2 volt I think given, yeah, 0.2. So
Yes.
IC can be found like 3 minus point means 2.8 by 1K, it's like around 2.8 milliamps. So IB like 2.8 upon 50. So roughly I think it should be around 56 charge per I think.
Okay. Samuel, have you find out? Set first.
IC equal to 3 minus 0.2 by 1 kilo ohm, madam.
So you have to take this
2.8 by 1
low.
kilo. 2.8 milliamps IC.
And what is the
So
then?
IB equals to IC into beta.
Okay. And then
2.8 into beta into 50.
IB equal to
140.
IC by 50. Okay. Then what is the value of IC? 2.8 I think. By 50. Then what is the value of IB? Shora? 56.
Remember the value of IB minimum.
Yes.
It is coming as 56
IC by
microampere.
beta. IC by beta.
Yes.
2.8.
So
56 microns, madam.
yes, 56. So next question. Generally, the gain of a transistor amplifies for a high frequencies due to the internal capacitances of the devices, coupling capacitance at the input, skin effect, and the coupling capacitor at the output. I think we already have solved this question.
It is for internal capacity.
Samuel, what is the right answer?
Due to coupling capacitor at the output.
No. Coupling
Option
capacitor
A.
will not play any role as high frequency.
Internal capacity of the device.
Yes.
High frequency. High frequencies due to internal capacitance, madam.
Yes.
High frequencies.
And next question is 26. Introducing a resistor in the emitter of a common emitter amplifier stabilizes the DC operating point against the variation in option A is the only the temperature, option B is the only the beta and the resistor, option C is the both temperature and beta, and option D is the none of the above.
For both temperature and beta, all the values.
Okay. Samuel, what is the right answer?
Ma'am, both will be the right answer. Temperature and beta.
Samuel?
Only beta, no, madam?
No, both the temperature and beta.
Both. Okay.
Actually, it is also discussed in the lecture.
Both
Yes. And please try to solve this question. A common emitter transistor amplifiers has a collector current of 0.1 milliampere when its base current is 25 microampere at room temperature. Its input resistance is approximately equal to dash. Note the here GT is given, which is 25 millivolts.
For this case, first we have to find the collector current, right? Because collector current is already given. So first we have to find the GM, transconductance. That is nothing but IC upon VT. So 1 milliampere by 25 millivolts. So 1 by 25, that is the GM in Siemens. So the input impedance Arpa is nothing but beta by GM. So beta we can find like IC by IV. IC is also given, IV given, from that we can find the beta. So beta by GM will give you the Arpa approximately.
Saurabh and Samuel, how you will
Ma'am,
calculate?
2 kilo ohm is the right answer.
Just
Thermal voltage is not required to calculate, madam?
no, the right answer is 1 kilo. Here you have to find out the RE19. The common emitter transistor amplifier has a collector current 1 milliamps. Okay, IC given. What is the base current here? 25 room temperature. The input resistance RE you have to find out.
Yes,
And-
1K is coming roughly.
You have to carefully see the VT is given. So just you have to put the equation that voltage, the thermal voltage divided by base current. This is because RE is the input current. The input side just voltage you have to divide it by base current. So we can get this one. Just take the simple equation. Okay.
VT by IP.
Saurabh?
Also we can find by using GM concept, no? From that concept. By using calculating the transconductance.
Okay. Then find out and then tell you what is the answer is. That is. So we can many way we can solve one equation. Just where find out the easiest way to find out the answer. Okay.
Yes.
So this is the next question. If the base width in a bipolar junction transistor is double, which one of the following statement is true? The current gain will increase, the unity gain frequency will increase, the emitter base junction capacitor will increase, or the RD voltage will increase. Can you little bit explain?
Because as you know, base to propagation is known as the early effect, where if we increase the reverse bias of the base to collector junction, then the effective base width will decrease. So that means the base width, the diffusion region towards the base will increase as we are increasing the reverse bias in the BCB collected to base. So that's why my base width will reduce, effective base width will reduce, and due to this reason, more and more current will come, and as a result of this, my IC will increase with the increase of the BCB. So as my IC is now increasing with an increase in PCB, so if we plot the output characteristics, we will get into VA, that is the early voltage. So the early voltage will increase.
And we don't okay. So by
But
equation
it
we
is
can
anyhow the base side is actually increasing, not doubling. Actually, if the base side is reducing, in that case, whatever the explanation is saying, that is correct actually. Because in that case, the effective length will be less, so more and more current will be increasing. Means most of the current emitted start period injected by the emitter, they will easily pass to the collector side. So in that case, current should be high, but here the base is actually doubling. So in that case, we can say like current gain that too will be less, because in that case emitter injection efficiency will be less. So alpha will be less and beta will be less. But here current gain
yes.
is increasing.
See, if the base width is increases, it means IV value is increase. Okay. And from this equation you can see that. And if IB is increases, then IC value will decrease. Because IC value in decrease, in that case you can like if the base region is bigger. Okay. So number of what it is stating, like recombination also increases. So IC current will reduce now. In that case, if the base width is increases, so in that term we can see we can tell that the IC is reduces. So number of recombination is increases. Okay. So from this equation you can see if IC and what is the relation between this early voltage. Okay, if IC is decreases, then you can tell that the VA will increase. Okay, so in from this equation you can satisfy that if the width of the base is increases, in that case the number of recombination will increases. So IB increases but IC will decreases. Okay, so IC decreases, it means the early voltage is increases. So the right answer is the fourth option. So question number 29, if the collector current changes from the 2 milliamps to 3 milliamps in a transistor, when collector emitter voltage is increased from 2 voltage to 10 voltage, what is the output resistance? This is very easy question. One or two more question we have to do.
Ma'am, del VC by del IC.
Yes. So the output resistance is del V by del I. The change in voltage by change in current.
8 madam.
And yes, 8 kilo. I have to write or we can go for the next question. I think time is over.
Next question.
So this is the question number. This is the question number 30. A change of 200 millivolt in emitter base emitter voltage causes a change in 100 microampere in the base current. Find out the input resistance. This is also very easy question. The change in voltage is given, change in current also given. So you have to find out the resistance. Yes, the value is 2 kilo. Can I move for the next question?
2 kilo ohms.
Yes. And this is the last question. For a single stage transistor amplifier, the collector load is RC equal to 2 kilo ohm and the input resistance RI equal to 1 kilo ohm. If the current gain is 50, then calculate the voltage gain of an amplifier.
It's a minus 100.
How you have calculated? Can you please explain?
For common emitter configuration, the overall gain we can write like minus beta times RC upon RE.
Okay.
So beta is given
50 and then
kilo ohm and RE is 20.
Samuel and Shoram. That's the right answer.
Formula madam.
Ma'am, please 1 minute.
In also in a previous question we have discussed here when the how to calculate the voltage gain if the current gain is given. The voltage gain equal to the current gain and the output resistance by the input resistance. Okay.
AI.
Simply take that the voltage gain equal to the current gain into the output resistance by the input resistance.
From 100 we decide to
Yes. Just take AB equal to
100
current gain.
AB is equal to current gain into output resistance RC by RE.
This is the last question. So can you please suggest me if do you anything need in these slides? So I can also improve if anything is needed. Any new I have to increase the numerical question, or I have to increase the MCQ question, or I have to teach some theoretical portion. Anything?
Ma'am, the track is okay for me.
Someone?
50-50 is fine, ma'am. Yes, I also agree with him. 50-50 is okay, ma'am. And ma'am, if possible, in the next session of Tuesday, if possible, can you please explain the second order difference of BJT? Or something.
Okay. Okay, if it is possible, then I will explain.
Is it the first class or some classes are already done?
No, it is the second session for the NPTEL microelectronics and circuit devices.
Okay. The timing is 6 or like
Yes, every Tuesday 7 to 9 p.m.
okay. So can you just fix like 8 started from 8 p.m. because I came from office like this
Actually,
time.
it is not in my hand. Actually, this is decided by. Actually, I have how the time is fixed. First, we have to submit the time.